All right, we are gonna do the copper cycle lab. So what I've already done here is masked out about 0.1 grams of copper, and we're gonna add some nitric acid to it. The formula for copper, by the way, is Cu, and nitric acid is HNO3. All right, so I'm gonna add about 2 milliliters of the nitric acid to the copper, and then I'll hold this up so that you can see it. Ooh, I can already see some stuff happening here. I'm gonna trap it with this watch glass. Notice what color the gas is. Ooh. And notice what color the liquid is that's left over. So one of the things that we noticed in the vials was that there were a couple of blue liquids, and one of them was CuNO3 and another one was CuSO4, and both were blue liquids. But if we added HNO3 to Cu, then we could not have made CuSO4 because those are not the right elements. So this actually in here is the copper nitrate solution, just like we saw in the vials. I'm still letting it fully react all the way before we move on with our next step. So I'm going to keep swirling it. It takes a couple minutes, and then all of that brown gas will be gone. And that brown gas has nitrogen and oxygen atoms in it, and it's just not good to breathe in, which is why we're doing this all in the fume hood. All right, and the next thing we're going to do is we're going to just be adding a little bit of water to this, just to dilute it a little bit. So this is 25 milliliters of distilled water. Okay, so nothing interesting chemistry-wise there. We just diluted the solution a little bit more. But next we're going to add some sodium hydroxide to this. Ready for this? Whoa! Check this out. We're adding NaOH to the CuNO3 too. So guess what we made here? One of the blue crystals that was in the vials was copper hydroxide, CuOH2. And so since we just added NaOH, those are what the blue crystals are in the bottom. So we're going to put these on the hot plate, and we're going to heat this for a couple minutes. It says in the directions to do this on about a 4, but for the sake of the video, I'm going to turn it up a little bit. Don't try this at home, guys. And I'm going to use a stirring rod and just stir this up a little bit. We'll kind of check back in a minute. Meanwhile, over here, I'm going to get my funnel ready to go with my filter paper. And because I read ahead, and one of my steps is going to be I'm going to be filtering the solid from the liquid. See, it's starting to turn a little bit darker there. It's not done yet though. Keep heating it. Bottom's starting to turn. And then another thing too, to be efficient when you're trying to perform a lab, is to get your next thing ready to go. So for example, I know that we need 15 milliliters of sulfuric acid ready to go for just a little bit from now. So I got that ready, and I also masked out 0.1 grams of zinc. So that one is ready to go too for when we need it. This is heating really fast now. Turn it down a little bit. You can see it's completely changing color from that light blue. It's going to go to this dark blue, and then it's going to turn completely black. We're looking pretty black right now, so I think I'm going to turn this hot plate all the way down. And I'm going to use some beaker tongs to take this off. Set it down. And I'm going to let that cool for a second here. And in class we actually let it cool for about 5 minutes, but since this is a speedy video, I'm going to start filtering this right away. So I'm going to go ahead and I'm going to pour this into my filter paper. And what's really cool about this, I can hold it up a little bit here, is the liquid that's coming out is totally clear, and we're going to have like a black gooey sludge on the top. So let's talk about what the black stuff is. We had copper hydroxide as the blue crystals on the hot plate, and what we did was we drove water off of those crystals. So if you've got CuOH2 and you get rid of some H2O, what you're left with is a black powder, which is copper oxide, one of the other things on the vials table that we did. So this is looking pretty good, and it's totally okay for this filtrate, is what the liquid is called, to go down the drain, because I don't see any bluish color, which would indicate that there was copper in there. But just because I'm in the fume hood here, I'm going to get rid of this waste and put it into the copper waste. Alright, next step in the lab is to scrape the black goo off of the filter paper back into your original beaker. So I'm just going to take a scoopula and get that black goo out of there, and we don't need this filter paper anymore. That's going to go in the garbage. Okay, and then I'm going to take this filtrate. Even though this one could go down the drain, I'm just going to pour it in there for convenience. So we've got the black goo now, and remember what I said, we're going to add that sulfuric acid, H2SO4, and we're going to stir this up. Ooh, check that out. We made another light blue liquid. So let's think, we just added H2SO4, and one of the blue liquids was CuSO4. So this is actually copper sulfate solution now. So woohoo! All right, we are going to add the zinc in and stir up the zinc. The solution's supposed to get a little more clear. Just depends on how much zinc you're adding and how much copper was in there. But the real fun is going to be in our last step, because we're going to do one more filtration here, and we're going to see what the solid that we've got left here is. So one more time, I'm going to take my funnel, my filter paper, and I'm going to pour my solution into here. And we're just going to give this a second. This time you'll notice that it's not coming out clear. This copper sulfate solution, there's still some copper in it, and copper's not safe to go down the drain, so that's why we collect our waste, and King County has special employees that come and collect the waste from us so that we don't just dump it down the drain and kill our fish. That's just being ethically responsible. And check out this reddish brown powder that's kind of floating in the top here. You can see some stuck to the edges. Believe it or not, that is the original copper that we started with, that I showed you in that very first beaker. So students always ask, like, what was the point of the whole lab? We just got the copper back. Well, it was to show you that copper was there all along. So matter is conserved. We just took copper on a journey, and we basically caused it to react in different compounds, and we saw so many color changes, right? Different light blue solutions. We saw the black stuff. We saw the dark blue crystals, and now just pure copper again. It's that reddish brown color. So that's why chemistry is so awesome.